Hi everyone, this is Poonam. Today we are going to discuss what is software testing and its basic concepts. So now we will see what is software testing. Software testing is the process of validating and verifying the software program and application. We can define software testing in many ways, in different ways. The next definition of software testing is process of finding defects, that is, variance between expected result and actual result. Process of executing a software program application with intent of finding defects. Means software testing means verifying the products is working as expected or not. Means to check the actual expected result is matching with the actual result or not. Software testing we can do in a two ways, manually or automation with automation. We, Now we will see types of the testing. There are two types of testing, functional testing and non-functional testing. You can see in functional testing there are different types. Unit testing, integration testing, smoke testing, UAT, localization, globalization, interoperability and so on. Unit testing means it is performed by developer at white box testing to check the developed part is working as expected or not. Integration testing means to check the path of the two components is working fine or not. There are so many different types of the functional testing. We will discuss in detail in further video. Like that, non-functional testings, there are also types of that non-functional testing. Performance, endurance, load, volume, scalability, usability testing and so on. Now we will see why testing is necessary. Nowadays, most of the things are working on the machine. So, and machines are working because of the software. If software will not work properly, then there will be no use of the machine, and there will be mission failure for the everyone. That's why testing is necessary. Software testing is necessary to make sure the product is defect free and meets as per customer requirement. Means testers first mission is to give the 100% bug-free product to the customer. Software testing identifies faults whose removal increase the software quality and increase the software reliability. As as by testing quality of the software will be increased, like that reliability of the software will also increase. Just now we discussed that because of mission failure, it is important for the testing. Impact on operational performance and unreliable if not done properly. So these are the things because of we testing is the necessary. Now we will see when to start testing. Testing starts right from the requirement phase and continues till release time. If requirements related defects caught later in the SDLC, result in higher cost to fix that defect. Means we have to start the testing from the starting phase only. First phase is of the requirement phase. If we start testing from the requirement phase, then cost of the fixing bug can be reduced. Suppose if we got defect in a further process, then cost of fixing that bug will be high. So it is better to test from the starting phase. Now see when to stop testing. There are four approaches to stop testing. First one is when test cases are executed. When all the test cases written by the tester executed successfully, then we can stop testing. Second one is when there is project deadlines. Suppose customer given deadlines of 5 months or 1 year, but still project is not completed. Then we have to stop the project by the deadline. Third one is test budget has ran out. If the budget is ran out of the project, then we have to stop the testing. Suppose we got a defect and cost of fixing the defect is very high than leaving the defect. Then we can stop testing there. We can leave the defect. Fourth one is coverage of code. Functionality or requirement reaches to the specific point. Means after execution all the product, after executing all the test cases or developing the product, we meet the customer requirement, then we can stop the testing. These are the approaches to stop the testing. Participants in testing. Who can perform the testing? Testing can perform by user, developer, tester and customer. User who is using the application, he is it means he is testing the application. Developer developing the application. Chances are there while developing the application he can got the bug. That means he is doing the testing. Tester's job is to test the application. Customer. Customer who is using the software means that is mean also he is testing the application. So these are four persons involved in testing: user, developer, tester, and customer. Now we will discuss testing principles. There are 6 testing principles. On this basis, testing works. Testing is a context dependent. Testing is context dependent means in small module more defects can found. By the it is declared that 80% of defects can found from the 20% of module. It is declared by the principle. Second principle is exhaustive testing is impossible. Yes, exhaustive testing is impossible because exhaustive testing means to test the application using all type of inputs. But it is not possible to test using all type of inputs because suppose we have small data, like we have to test we have to test from the yeah, we have to give an age between 18 to 20, then we can check by 18, 19, 20. We can give all type of data, but suppose we have huge data like 100,000, we can't do it manually by using all data. We can use this by using automation, but by automation also if we have huge amount of data like billions, millions, then we can't do it. That's why exhaustive testing is impossible. So instead of this, we use the inputs on the basis of risk and priorities to focus testing efforts. Third principle is early testing. Just now we discuss early testing in this video. To start testing in early phases, it is important because if we got a bug, then we can reduce the cost of the fixing the bug. So early testing is important. Fourth one is pesticide paradox. If same test cases is repeated over again and again, then we can't find new defects. To overcome that, we use pesticide paradox. Means to test cases should be reviewed and revised again and again. By using this, we can get new defects. Suppose we are repeating the same test cases again and again. First time we are testing it, we can get more defects. But second time we can, if we testing same test cases, then we can get less defects. Like that, testing same test cases again and again, then there will be no any defect at the end. So that's why we have to review the test cases again and again. Fifth one is testing show presence of defects. Testing can show that defects are present but can't prove that there is no defect. Means it is not we can't prove that tester tested the defect application, but we can't prove that it is 100% bug free, because it is possible that tester unable to find the bug. So the testing shows presence of the defects. Testing never shows absence of defects. It always shows presence of defects. Last principle is absence of error fallacy. Finding defect and fixing does not help if system build is unusable and does not meet customer requirement. Suppose the product is developed and it is 100% bug free, but it was tested by the wrong requirement and it is not useful for the customer. So in this case, it is called as the absence of error fallacy. If requirement are given wrong and test are given 100% bug-free product, but it is not useful, then there is no use of the product. So these are the testing principles we discussed. Now we will see SDLC stages. SDLC is software development lifecycle. There are 7 stages of the SDLC. First one is requirement gathering. Requirement gathering, in this, BA will gather requirement from the customer and BA will convert CRS into the BRS. BRS means Business Requirement Specification. It is also called as URS, SRS. Second stage is analysis. Features and functions that need to be put into project and determine or analyze. Analyzing means analyze the features that should be what features should be in the project and what functionality should be done to develop the project. That all analysis done in this phase. Third one is design. It is done by chief architect. It has a two types: high level design and low level design. High level design is done by the architecture. It is a architectural design, means it is a seen part which is we can see by our eyes. It is a high level design. And low level design is performed by developer. It is the internal part of the software. Fourth one is development. Based on the design document, small modules are summed together and developed. In development, by using third phase, design phase, by using this design, developer develop the application which are required. And fifth one is testing. After developing, tester tests the application developed by the developer. In testing, different type of testing are performed: functional, non-functional. Sixth is the implementation. Engineers with coordination of developer will implement the developed application. Maintenance. Testing team will suggest to change the software if necessary. Maintenance means after delivering the product to the customer. If customer uh, require help for the application, then we have to give service to them. These are the stages of SDLC. Now we will see software process. A software process specifies a method of developing software. A software project, on the other hand, it is developed project in which a software process is present. Means software project is means it's the process of developing the software. A software product is a final outcome of a software project. Software product means the project. Project means the process of the developing the product. Then that's why the final outcome means it is the product. So it is a process of process, project, and product. These are the things we will discuss today. Further part we will discuss tomorrow. Thank you.